Okay, picture this. A really critical piece of machinery. It just grinds to a halt. Maybe it's on, say, a massive cargo ship, right?
Mhm.
And you find out the bolt holes in a crucial coupling are damaged. Your mind probably jumps straight to a really lengthy and, well, expensive workshop repair.
Mm.
That means the whole headache of dismantling everything, the logistical puzzle of transport, significant costs, and potentially weeks of the ship just being out of service. Frustrating doesn't even cover it, right?
Oh, absolutely. It's a scenario that sends, well, shivers down the spines of operations managers everywhere. In industries where downtime means just hemorrhaging money, thousands, maybe even tens of thousands of dollars lost per day for a vessel like that, the traditional fix, it can feel like a punishment in itself.
Exactly. But what if there was another way? Our sources today explore a really um, compelling solution:
Uh,
on-site restoration, using a specialized portable inclined hole and internal cavity drilling and reaming machine.
yeah.
Imagine just bypassing that entire disassembly and transport nightmare.
Right.
We're talking about getting things back online much, much faster with significantly lower costs.
Mm.
It really feels like a game changer in how we approach these kinds of heavy-duty repairs.
It is. And what's fascinating here is the fundamental shift in strategy. Instead of taking this massive piece of equipment apart and hauling the damaged part off to some special environment, we're bringing a highly specialized capability directly to the problem, wherever it might be.
Precisely. So for this deep dive, our mission is to really understand the nuts and bolts,
Yeah.
pun intended, of this
Yeah.
technology. We want to explore how it works, what it's truly capable of, and, well, why it represents such a significant leap forward for various industries.
Yeah.
We've taken the sources you shared with us and distilled them down to the most critical information about this innovative repair method.
Good. And I think to really appreciate the impact of this technology, it's important to first understand why those damaged coupling bolt holes, for instance, are such a critical issue to begin with.
Right. Good point. Let's zoom in on that. Damaged bolt holes in a ship's coupling. Why are they such a major point of concern?
Well, in a ship's propeller shaft system, these bolt holes, they play an absolutely vital role. They are responsible for transmitting the immense torque that's the twisting force turning the propeller that the engine generates. So for the ship to move efficiently, deliver its power, you need an incredibly precise and secure fit between those coupling parts.
That makes perfect sense. So what kind of damage typically happens to these critical connections then?
Well, over the lifespan of a vessel, those bolt holes endure tremendous stress, just constant torque transmission.
Yeah.
And even routine maintenance, taking things apart, putting them back together, that can introduce wear and tear. We often see scoring on the inside surfaces, maybe some deformation of the hole shape. And over time, they can even become slightly oval, which really compromises that critical tight fit.
Ouch. Yeah, an oval hole trying to fit a round bolt doesn't sound like a recipe for stability at all.
Exactly. It really diminishes the ability to properly tighten the bolts. These bolts are often pre-tensioned, right, to create a strong frictional connection between the coupling flanges. And it's this friction plus the precise fit of the bolt shank in the hole that lets the coupling handle those huge forces reliably. If the holes are damaged, well, the whole integrity of the connection is at risk.
So, as we touched on earlier, the traditional solution is that whole ordeal disassembly, shipping to a workshop. Can you maybe elaborate a bit more on why that's such a huge logistical and financial burden?
Oh, it's massive. Beyond just the direct cost of the repair itself at the workshop, you're looking at this cascade of negative consequences. The most significant, as I mentioned, is the downtime for the vessel. Every single day, a large cargo ship isn't operating. It's losing potentially tens of thousands of dollars in revenue, easily.
Hmm.
Then you have the sheer complexity of physically removing and transporting such a large, heavy component. It often needs specialized gear, permits, and of course, once the repair is done, the whole process reverses more time, more cost for shipping it back, and then the really intricate task of reassembling everything precisely.
It just sounds like a massive ripple effect of delays, logistical headaches, and just escalating expenses.
Precisely. And that's exactly why the on-site approach is so incredibly compelling. The source material even highlights that sometimes instead of just restoring a damaged hole to its original size,
Yeah.
they can actually use this machine to enlarge the worn hole to a specific, slightly larger diameter, and then they fit a new custom-sized bolt right there on the spot. It's a really clever and efficient workaround.
Okay, that is smart. A really clever way to handle wear. But this brings up a crucial question for anyone listening. How do you actually achieve that level of accuracy? Especially when you're fixing a hole that might be misaligned, or maybe deep inside some massive structure,
Right.
all without the controlled environment of a workshop. You can't exactly uh, put the whole ship on a milling machine, can you?
No, you can't. And that raises a fundamental question, right, about the precision and the versatility of the equipment itself. You can't just bring a standard drill press down to the engine room and expect workshop quality.
Exactly. So let's get into the details of this specialized machine, the inclined hole and internal cavity drilling and reaming machine. What exactly makes it so unique?
Okay, so at its core, it's a portable but incredibly robust machine tool. It's specifically engineered for high precision work on equipment that is simply too large or too integrated to be moved easily. Think of it maybe as a self-contained mobile workshop designed for really heavy-duty applications. Its key advantage. It lies in its ability to drill and ream holes not just straight on, but at a wide range of angles, and even inside those hard-to-access internal spaces. It's built to handle tough materials, like high-grade steel, and designed to operate effectively in, well, pretty much any orientation you can imagine.
Okay, so it really is like bringing a workshop-grade tool directly to the job site. Let's delve deeper into its specific capabilities then. The name itself, inclined hole and internal cavity drilling and reaming machine. That gives us a pretty good start.
It does. It's specifically designed for tasks that traditional fixed machine tools just cannot perform on site. So the ability to drill inclined holes that aren't perpendicular to the surface, that's a primary function. And just as important is its capacity to operate within confined internal cavities. That's essential for repairing damage in areas that would otherwise need huge disassembly just to reach.
Right. And our source gives some specific details about what these machines can actually handle. Let's talk specs. What kind of range are we looking at here?
Yeah, for instance, the source mentions a diameter range. Some machines can work on holes from, say, a 30 millimeter up to 125 millimeter. That's a pretty significant range, covering a lot of common bolting and connection sizes in heavy industry.
Okay.
And when it comes to those inclined holes, the spindle, the part holding the cutting tool, often has considerable movement. 45 degrees left and right is a common specification mentioned. But more versatile, sort of universal models, they can even achieve a full 360-degree rotation and maybe a 90-degree swivel up and down.
Wow, that level of articulation sounds absolutely crucial for navigating, the complex shapes of large machinery and getting into those awkward spots.
Precisely. And a detail that might seem small but is actually vital for on-site work is the sealed lubrication system. This lets the machine be mounted and run in pretty much any orientation, horizontal, vertical, even upside down, without any risk of lubricant leaking out. Ensures consistent performance. And while portability is key, these machines are also built powerful. Serious horsepower to tackle tough materials. Yet they often have a relatively lightweight structure to make setup and handling easier.
So you're not really sacrificing the muscle for the mobility then?
Not at all. They typically have stepless speed regulation, which gives the operator really fine control over the cutting speed. You can optimize it for the specific material and the machining task. They also maintain constant torque, which means a consistent, powerful cutting force for efficient and accurate material removal. The source even mentions some impressive single-sided feed rates, over 5 millimeters in some cases. That shows how quickly and effectively they can work.
That is impressive speed for such precision work.
Yeah.
And what about the quality of the finished hole? Because, for a secure bolt connection, you need a really smooth and accurately sized bore.
Absolutely critical. The surface roughness achieved by these machines is often R1.6 or even better. To give you a sense of that, R1.6 is incredibly smooth. It's like a polished metal surface you might find on precision instruments. This ensures an excellent fit for the bolt and optimal performance of the whole connection. And to make operation easier on site, many of these machines have motorized movements for adjusting, say, the arm height or tilting the machining head. That allows for fine-tuning and precise positioning with less manual effort.
It sounds like a really sophisticated and, thoughtfully engineered piece of equipment. Now, we started by talking about ship coupling bolt holes, but the name clearly suggests broader uses. What other kinds of machining tasks can this thing handle out in the field?
Right. If we connect this to the bigger picture for you listening, the fundamental advantage is the ability to precisely repair or create holes. On large, immovable structures where moving the whole assembly to a workshop just isn't feasible, practically or economically. And in all these cases, maintaining high precision is absolutely critical.
So beyond just drilling and reaming, what other machining capabilities do they offer on site?
The source highlights several key tasks. Naturally, they excel at drilling and reaming to get that precise final diameter and smooth finish we talked about. They can also perform tapping. That's the process of creating internal screw threads, essential for installing bolts and fasteners. And in some cases, depending on the model and maybe attachments, they can even handle light boring or milling operations for more complex surface prep.
Right, so going back to the ship coupling example, we're not just limited to fixing existing damage, are we?
Exactly. For those damaged ship coupling bolt holes, using this on-site machine just eliminates that whole cumbersome removal process. The machine is brought right to the job. It means a significantly faster repair, which directly improves the reliability of the ship's power system and, crucially, dramatically cuts down maintenance downtime. Line boring that's precisely enlarging an existing bowl to make it perfectly round into a specific larger size, often for a new slightly oversized bolt. That's another key application. And as we mentioned, tapping allows for creating new threads if the old ones are stripped or damaged.
So the overall capability is really the precise creation or restoration of critical holes on components that are just too massive or too integrated to move easily.
That's the core value proposition, yes. Now, when you're doing this kind of high precision work outside a controlled workshop, a natural concern you might have is, well, the level of accuracy
Mhm.
and the quality of the finished surface. Can you really get workshop level standards out in the field?
That's exactly what I was thinking. It almost sounds too good to be true.
Yeah.
You know, getting that kind of precision in a shipyard or a mine site.
It's a valid question, a really important one. But these machines are specifically engineered to deliver exceptional accuracy, even in challenging on-site conditions. The source indicates achievable tolerances can be between 0.0001 and 0.005 inches. That's incredibly precise. We're talking measurements that are like a fraction of the thickness of a human hair.
Wow.
And as we discussed, the surface quality can consistently hit R1.6 or better.
Okay, those are genuinely impressive figures. What are the key factors that let them achieve that level of precision in, let's face it, a less than ideal environment?
Well, several design and operational factors come together. That stepless speed regulation, combined with the constant torque output, ensures a consistent, controlled cutting force. That's essential for both accuracy and finish. The inherent rigidity of the machine's structure, even though it's portable, plus highly precise feed mechanisms, that guarantees the cutting tool follows the intended path without unwanted vibration or deviation. Of course, the quality of the cutting tools themselves is crucial, and the skill of the operator is also absolutely critical. And the strategic use of cutting oil or coolant during machining helps dissipate heat, lubricate the cut, and further enhance the final surface finish.
So it's a real combination of advanced engineering in the machine itself and the skill and attention to detail of the person running it.
Precisely. And for highly regulated industries like marine, this level of precision isn't just, nice to have. It's often a necessity for meeting the really stringent standards set by international classification societies. It ensures safety and long-term reliability.
Okay, so we've talked a lot about ship couplings, but as the name implies, the applications for an inclined hull and internal cavity drilling and reaming machine must go way beyond the maritime industry. What other sectors are really leveraging this on-site machining capability?
Yeah, if we broaden our view, these machines offer huge advantages to basically any industry that relies on large, heavy equipment where precision hull machining is critical and where the logistics of moving components are just prohibitive. The source actually gives a really comprehensive overview of the key sectors benefiting.
Okay, let's walk through some of those. We've covered marine pretty well, of course. What are some other notable examples?
Well, in the heavy construction machinery sector, these machines are frequently used to repair worn or damaged pinholes. Think excavator booms, loaders. Another prime example of large, heavy, often immobile equipment where on-site repair is really the only practical choice.
Ah, right, like on excavators. Makes sense.
The mining industry also benefits significantly. They use them for repairing fixed holes, like those for the spring seats on large vibrating screens. Huge pieces of kit.
Got it. What about power generation?
Power generation is a major area. This includes on-site machining of things like turbine shafts, generator parts, and even correcting misaligned flange connection bolt holes in wind turbine towers. Those are just colossal structures. Transporting a major component there is a monumental task.
Right, those wind turbine towers are absolutely enormous. I can see why you wouldn't want to move them.
Exactly. The petrochemical industry uses this technology for critical tasks too. Things like repairing bridge tube holes and heat exchanger tube sheets, vital components in processing plants. Even the aerospace industry finds uses for these machines, working on large aircraft structural parts that are just too cumbersome to move easily. And finally, in general heavy manufacturing, they're used on steel structures, boilers, large containers, even cement plant furnaces, basically any large-scale fabrication where precision hull work is needed.
So it truly spans across almost any industry dealing with substantial, difficult-to-move equipment, where downtime and logistical challenges are just major economic factors.
Absolutely. The overarching benefit that resonates across all these diverse sectors is really the same: significantly reduced downtime and the complete elimination of those complex and costly logistical nightmares associated with shipping massive components offsite.
Okay, let's try and synthesize all of this then. The core message here seems to be that accurately restoring critical bores, like those ship coupling bolt holes we started with, without that whole protracted, expensive workshop transport process, is now a tangible and efficient reality, thanks to these highly specialized portable machines.
That's precisely it. These machines bring a remarkable level of precision, speed, and substantial cost savings directly to the worksite. They minimize operational disruptions across a surprisingly diverse spectrum of industries. And when you consider that downtime can cost companies tens, maybe even hundreds of thousands of dollars per day, the ability to perform these repairs on site represents a truly significant economic advantage.
Which, for you, the learner, means that those really daunting scenarios of critical equipment failures don't automatically have to mean weeks of crippling delays and astronomical repair bills anymore. There's now a smarter, much more efficient alternative out there.
Yeah.
And it really makes you think, if this level of sophisticated machining capability can be effectively deployed directly to these massive industrial sites, what other unexpected fields might be on the cusp of a similar revolution in maintenance or maybe even manufacturing processes? Certainly a fascinating prospect to consider.